In this short video, we're going to analyze the effects of a government purchase program. Let's suppose that the supply and demand curves for milk are given by quantity demanded equals 110 minus 10p and quantity supplied equals 40p minus 40. In this scenario, Q is in millions of gallons and P is the price per gallon. We are told that in the absence of government intervention, the equilibrium price in the milk market is $3 per gallon and 80 million gallons are produced. Now let's suppose that the government has instituted a price support program for milk and they're placing a price floor at $5 a gallon. Under this program, any unsold milk is going to be purchased by the government and turned into cheese. So it's a government purchase program. That price is going to be supported by purchases from the government. We want to figure out how much the government's going to spend on this price support program, as well as how much deadweight loss is going to be generated. What do we need to know to answer this question? We need to know the demand curve, the supply curve, as well as the support price. So let's solve this question. Here's what we know. We know the demand curve, the supply curve, and the support price. We are trying to find the cost of the support program first. In order to do this, we need to figure out how much the government needs to purchase when the price is supported to $5. This is actually a relatively simple exercise. We need to figure out the difference between how many units are demanded by the market and how many units are supplied at this support price of $5. And the government is just going to buy the difference. So the quantity demanded is 110 minus 10 times 5. 110 minus 50 is 60 million. The number of gallons of milk supplied at the support price of $5 is 40 times 5 minus 40. 200 minus 40 is 160 million. So notice the problem here. The number of gallons of milk supplied is 100 million higher than the number of gallons that are demanded. So what is the government going to have to purchase in order to support this artificially high price? They're going to have to purchase the difference. So they're going to purchase the difference between the quantity supplied and the quantity demanded, which is 160 minus 60, or 100 million. So we know how much the government needs to purchase. The question that we're trying to answer is the cost of the support program. This is just a multiplicative exercise. The government spending is, well, they're going to purchase 100 million gallons. Each gallon costs $5, the support price. So government spending is just $5 times 100 million gallons of milk, which is $500 million. So it's a very expensive program. Now we are ready to find the deadweight loss associated with this government purchase program. The easiest way to think about this deadweight loss is that it's this purple shaded region in my graph. So I just want you to notice what I've graphed: a supply curve, a demand curve, as well as the support price. I've labeled the equilibrium, which the question provided, $3 and 80 million units. I've also labeled the math that we did in the previous slide where we found that 60 million gallons were demanded and 160 million gallons were supplied. So nothing that's labeled here is something that we didn't already know. I've just sort of labeled the work we've already done. So this purple shaded region, what is this? This is the deadweight loss, and it's really the government spending that doesn't result in new surplus. So the government spending is this entire giant rectangle. But part of that government spending is translated directly into additional producer surplus. This is the additional producer surplus. So that part's not really deadweight loss. So the deadweight loss is the purple shaded region. The fastest way to compute this purple shaded region. So what we're going to do is we're going to take the government spending, which is the whole rectangle, and we're going to subtract the triangle formed by demand, supply, and the price support. So deadweight loss is just equal to 500 million minus 1/2. The height of this triangle is 5 minus 3, and the length of the triangle is 160 million minus 60 million. So that's 100 million. So if we do a little math here, we get $500 million minus $100 million. Why is it $100 million? Because 1/2 of 2 is 1. And 500 million minus 100 million is $400 million. So that's the fastest way to compute the deadweight loss when we're looking at a government purchase program.